All right, so this is my code final project for Engineering 103. As you can see up here on the door, we have the ESP32, and it is sitting in front of a small but very powerful magnet, which is going to be detected, the magnetic field is going to be detected by the Hall effect sensor that is within the ESP32. So then I just have a super long micro USB cable that I snake all the way around to my computer so that I can get a direct line in. And then on the computer code side of things, this was my initial code. It goes through a long series of checks to connect the ESP32 to Wi-Fi. And then using that Wi-Fi connection, it communicates to a third party to transmit data from the ESP32 directly into a Google Sheet over the internet. But for the life of me, after trying for a solid 6 or 7 hours, I could not get it to actually communicate over Wi-Fi. So instead, we just have it recording here to serial. You can see up here, every 10 minutes it takes an interval, or every 10-minute interval it takes a reading. You get your average values, you get your maximum values, you get your minimum values, you get your rolling averages. And this is the code for that. It's pretty simple. It's just basically using a loop to read the sensor value from the Hall effect sensor, check if it's a new maximum, check if it's a new minimum. If so, it assigns that new value to the max and min variables, and then it waits, and then it counts, it takes the sensor readings, adds them to the sum variable, and then adds a count up so that you know how many readings you've taken. Then it weights whatever your specified interval is. In my case, I decided I was going to do 10 minutes, which is that in milliseconds because I'm using the millis function. And then I decided to wait 1 second in between each reading so that it wouldn't just be a massive constant stream of data. So that's 1,000 milliseconds. Then after all that is done, after all that's calculated, it calculates your average, it calculates your sum, it adds a count to the total average value so that you can calculate your rolling average for the entire time you're collecting data. And then it simply just prints to serial your average values, your max values, your min values, and your rolling average. And then if for some reason it hasn't got any valid readings because the ESP32 is messed up, then it just sends an error message basically. Then it waits a second and does the whole process again. And so every 10 minutes, you're getting some sort of, you're getting your information. Then, once I have all of this data, I take it, I plug it into an Excel spreadsheet. Here I've gone ahead and separated all of the just pure values, and I've graphed them alongside time in 10-minute intervals because Excel wasn't really able to deal with the time signature that the ESP32 was giving me. So I just have it set up in time in 10-minute intervals. So there's 158 intervals, which represents about 27-ish hours of data collection. And then I take all that information and I graph it. So over here, I have the time versus average values. I have the time versus your rolling average. I have the time versus max values and the time versus min values. And so looking at these data, looking at these charts, we can deduce a couple of things. So first of all, you can see that the average values and the rolling average values trend down over time. I think that honestly has to do more with just the ESP32's Hall effect sensor being kind of iffy. It wasn't really wanting to give me consistent readings all the time, but you can also see that the scale is actually quite small, so there's not a whole lot of differentiation. And these big outlier jumps that you're seeing are because that 10-minute average had, for some reason, a suddenly really big value, which indicates that the door is open. So the way that the Hall effect sensor is working is it's constantly reading values. Usually it's in the negative 300s, and then when the door is open, it's moved away from the magnet, so it's just reading ambient magnetic, which is in the negative 100s. You can see that here in the time versus max values. You can see that most of the time the door is closed. It's always down here in these like negative 300s range. And then these big jumps, those are times when the door was opened. And then the minimum values are pretty much always in the negative 300s because the value never gets any lower, right? The door doesn't get more closed. So that's my project. It was fun. I had a lot of stuff to mess around with and a lot of stuff to improve. I'm looking forward to doing some more ESP32 projects in the future, and I've definitely learned a lot from this.